So I'm going to start with the let statements here. I'm going to say let x hat be 1 meter east, and we're going to let y hat equal 1 meter north. These are my reference unit vectors. And now I will express the three given displacements in terms of these reference vectors. So the first one, I'll call it delta D1. That is 700 meters north. So that is simply 700 y hat. And then the second one is 500 meters west, so it's in the opposite direction of east. So I can say negative 500 meters, or no, just negative 500 x hat. The meters is already inside of the x hat through the let statements. The third one is where we're going to have to do some more work because it's on an angle. So I'll call that displacement 3. So this is 1.2 kilometers, which we need to convert to meters. East 30 degrees south. So I'm going to need to put that into components. So I'll draw my little diagram here. East, ooh, that is not straight. Let's try again. No. All right, that's the best one so far. So that's 1,200 meters. And let me draw horizontal and vertical components here. Labeling the angle 30 degrees. So that's east 30 degrees south. So it's just angled below the east line. So if I use 30 degrees as my reference angle, then the horizontal side, or the x component, is going to be the adjacent side. And the vertical component is going to be the opposite side. That lets me know if I'm using sine or cosine for each component. So the x component, the horizontal component, it will be cosine. So it's going to be 1,200 cosine 30 degrees x hat. And then the y component, we'll use sine. So it's going to be negative because it is going downwards, and positive y was defined as north. So let me change that to minus. I can go ahead and get those values in the calculator, though the second one's, if you know your special angles, sine of 30 is just equal to a half. So half of 1,200 is 600. Cosine of 30 is, I believe, root 3 over 2. So the square root of 3, that's an irrational number. So I'll just put that in the calculator here. So I'm getting 1,039. These would be the two sig figs, because we were given originally as 1.2 kilometers. All right, so that is the third vector broken down into components. And now I can go ahead and find the total. I'll use delta D sub TOT for total. So the total means I'm just going to add these three vectors. And I'm going to look at all the x components and put those together. So the first displacement is purely in the y direction, so no x component required there. The second vector, however, is got negative 500 for the x component. And the third vector has positive 1,039 for the x component. So that will give me the horizontal component. Now the vertical component, the first vector d1 has positive 700, and the second vector does not have a y component, but the third vector has a negative 600 y component. So just combine those numbers. So for the x, that will be positive 539. And for the y, it'll be positive 100. Okay, so at this stage, I will draw myself a right angle triangle that's got 539 going to the x direction, and 100 in the y direction. Nope. Having trouble with drawing straight lines here. And what I'm looking for is the hypotenuse. Well, I'll just switch some colors here. I am looking for the hypotenuse. And also the angle, because I want to communicate the direction at the end as well. You may ask, how do I know which angle I have to find? Well, it's going to be the one that's at the start of the resultant vector, at the tail of the resultant vector. Okay, so the magnitude is going to be found with the Pythagorean theorem. So it's going to end up being the square root of 539 squared in 100 squared. Get the calculator out. That is giving me 548. I've lost my pencil. There it is. This will be going to 2 sig figs, I believe. So I will do scientific notation. Okay, and now the angle will be the inverse tangent of opposite over adjacent, so 100 over 539. Look at that. Okay, getting 11 degrees here. And I can put those together to write my final answer. So 5.5 times 10 squared meters east, 11 degrees north. And that's it.